Welcome to this lesson on more function problems. Please make sure you have these notes in front of you so we can begin our lesson. For problem 1, it says, Jalen spends 0.75 hours swimming each day. Which answer choice is an equation that represents the total amount of time, t, that Jalen spends swimming after a certain number of days, d? So let's go ahead and identify two things. Let's identify our independent variable and our dependent variable. So just by reading the problem, anytime you see the word total amount of something, so in this case we have total amount of time, that is going to indicate that that is your dependent variable. So I'm going to put time, or total time, which is called t. That's my dependent variable. My independent variable is the other variable in the problem, which is d for days. So days, and we'll call it d. Alright, so now that we have that, let's go ahead and set up our chart. My independent variable, which is d, will go in the first column, and my dependent variable, which is t, will go in the second column. So if Jalen goes swimming for 0 days, he would have swum for 0 hours. If he goes ahead and swims for 1 day, he's going to swim for 0.75 hours. If he swims for 2 days, he's going to swim for 1.5 hours. And the last box, let's call it d because it could be any number. It could be 3, 4, 5, or 100. And then we're going to put a question mark in here because that's what we're trying to figure out. So let's go ahead and figure out the pattern. To get from 0 to 0.75, let's add 0.75. To get from 0.75 to 1.50, let's add another 0.75. So the pattern is to use repeated addition to keep adding 0.75 plus 0.75. So let's go ahead and draw our machine. In our machine, let's go ahead and multiply 0.75 because that's the shortcut to repeated addition. And let's check to see if this works. Let's put 0 in the machine. 0 times 0.75 is 0, so it works because both my time comes out as 0. So now let's go ahead and do this. So let's go ahead and plug in d into the machine, and when it pops out of the machine, we get 0.75 times d. But because they want an equation, we have to make sure we set it equal to t. So the total time is equal to 0.75 times d. And that's the equation. And the equation that represents that would be the last choice right here. For problem 2, it says Victoria earns $32 per hour at her job. Which answer choice is an equation that correctly represents the total amount of money, m, that Victoria earns after working for a certain number of hours, h? So let's go ahead and identify our independent variable and our dependent variable. Just by reading this problem, I see the number total amount of money, or our m, so that has to be our dependent variable. So I'm going to put total money, which we'll call m. And the other variable that we have is h for hours. That's our independent variable. So hours, and we'll call that h. So using this table, our independent variable would be h. So let's put h on the top row. And let's put m for money on the bottom row because the money depends on the hours. The more you work, the more you get paid. So at 0 hours, Victoria gets no money. At 1 hour, she gets paid $32. At 2 hours, she gets paid $64. Now for the next one, we could put 3, but it could be any amount. So I'm going to call it h. And if she works 8 hours, I don't know, or h hours, I don't know how much money she makes. So let's put a question mark there. Let's figure out the pattern. To get from 0 to 32, I add 32. To get from 32 to 64, I add 32. So the pattern is to use repeated addition to add 32 plus 32 plus 32. So let's draw our machine now. In our machine, instead of adding 32, we're going to multiply by 32. And let's check to see if this works. If we plug in 0 into the machine, 0 times 32 gets 0, so it's working. If we plug in 1 into the machine, 1 times 32 gets 32, so we get our value of m. So let's plug in h. If h goes into the machine, when it pops out of the machine, we get 32 times h. But we have to set it equal to m because it wants an equation. And that would be the equation, and the one that matches it would be the third one right here. For this problem, it says Noah plans on going to the amusement park this Friday. It costs $35 to enter the park, and then 75 cents for every ride Noah goes on. Which answer choice is an equation that shows the relationship between rides, R, and total cost, C? So once again, let's go ahead and start our independent variable and our dependent variable. I see the word total cost, so the total amount. So I'm going to put the cost down here, and the C would be our dependent variable. And the other variable that we have is R, so the rides would be the independent variable, and let's call that R. So let's go ahead and complete our chart. In the first column, let's put our R for independent variable, and let's put a C for the dependent variable, which is cost. The R means ride, and the C means cost. So this is a little tricky one, because if Noah goes to the amusement park and he rides on 0 rides, he's going to still pay $35 to get into the park. Even if he doesn't ride anything, he still has to pay $35 to get in. But then if he decides to go on 1 ride, he's going to pay the $35 to get in plus 75 cents. So $35.75 for 1 ride. And then if he wants to go on 2 rides, he would pay $36.50. Because basically you're just adding another 0.75 to that. So instead of this being a 3, I'm going to call it R, because it could be an unknown amount of number of times he goes on a ride. And I'm going to put a question mark because we don't know that yet. So to find the pattern, to get from 35 to 35.75, I'm going to add 0.75. To get from $35.75 to $36.50, let's add another 0.75. So the pattern says let's continue to add 0.75. So in our machine, instead of using a repeated addition, the shortcut is to just multiply by 0.75. So what I'm going to do is let's check to see if this works. Let's send in 0 into the machine. 0 times 0.75 gets me 0. So that doesn't work because I need it to say 35. So in order to fix this, I need to add a second machine. And if 0, I want to make it look like 35, I need to add 35 to it. Alright, so let's check to see if this works. Let's plug in 0 back into it. So 0 times 0.75 gets me 0, plus 35 gets me 35 now. Alright, so let's try sending R into there. If R goes into the machine, so R times 0.75 would be 0.75 R plus 35. And we need to set it equal to C, because we'll get C after we solve that. So that would be the answer. So the answer choice that you want to select would be the last one. So pause the video and complete this problem, and we'll discuss the answer in class tomorrow. So pause the video and complete this problem, and we'll discuss the answer in class tomorrow. So for this example, it says graph the relationship shown in the table. So let's go ahead and do that first. Our first ordered pair would be 5, 7. Because I'm taking it straight from the table, so 5, 7. So on the x-axis, let's go to 5. 5 is right here. Let's go up to 7. And our first dot will be placed right there. Our second ordered pair would be 6, 8. So the next one would be 6, 8. So on the x-axis, let's go over to 6. And let's go up to 8, which is about right here. Next one, let's go to 7, 9. So on the x-axis, let's go over to 7, which is here, and I'm going to go up to 9. And the last one, 8, 10. 8, 10. Let's go over on the x-axis to 8, and we're going to go up to 10. So notice all the points that we just graphed kind of form a nice straight line if I was to connect it. So let's go ahead and do that right now. Let's go ahead and connect all the dots to make a nice straight line, and if you notice, it can continue going in its opposite direction. So every dot that we placed forms a nice straight line. The second part of this problem says, which of the answer choices is a coordinate point that would not be equal to the relationship? So basically, which one of these down here are not on the line? So let's go ahead and graph the first one, 1, 3. 1, 3, 1 on the x-axis, 3 in the y-axis. So that one works. So that can't be an answer. Let's go to 2, 4. 2 on the x, 4 on the y. That one works. It's on the line. So that can't be an answer. Let's go to 3, 8. 3 on the x-axis, 8 on the y-axis. So that one is not on the line. So we know that that is not a relationship. Let's look at the last one. 5, 7. 5 on the x-axis, 7 on the y-axis. That one's on the line. So the only one that doesn't work would be 3, 8. So for this problem, it says use the relationship to complete the table. So they've given us the relationship right here. Y is equal to 1.5 times x plus 10. So all we want to do is take the numbers in the x column, plug it into the machine, and then that gives us our y value. So if I plug in 2 in for x, I can say 1.5 times 2, and then add 10 to that. So 1.5 times 2 is 3, plus 10 gets me 13. So this value is equal to 13. Let's plug in 4 into that. 1.5 times 4, add 10. So 1.5 times 4 is equal to 6. 6 plus 10 gets me 16, so the next value would be 16. The next one, let's try 1.5 times 6, then let's add 10 to that. So 1.5 times 6 would be 9. 9 plus 10 gets me 19. Let's try the last one. We're going to put 1.5 times 8. Let's add 10. So 1.5 times 8 gets me 12. And 12 plus 10 gets me 22. So we've just completed the table. So pause the video and complete this problem, and we'll discuss it in class tomorrow. Alright, for example 9, it says which answer choice shows an equation that correctly represents the relationship shown in the table. So the difference from this problem and the last problem is that the last problem gave us the rule. Now they're asking us to find it. So let's figure out the pattern. To get from 6 to 8, let's add 2. To get from 8 to 10, let's add another 2. To get from 10 to 12, let's add another 2. So if we draw our machine, inside of the machine, instead of saying plus 2, plus 2, plus 2, the shortcut to that would be to multiply by 2. So let's see if this works. Let's plug in 1 into the machine. 1 times 2 gets me 2. But I need it to say 6. So what we have to do is we have to build another machine. And if we're at 2, let's add another 4 to get to 6. So let's try it now. Plug in 1 into the machine. 1 times 2 gets me 2. Plus 4 gets me 6. So now I got 6. So let's send an x. Put x into the machine. X times 2 gets me 2x. Then we're going to have to add 4 to that. And then since we want to write an equation, we have to set it equal to y. So 2x plus y equals 4 is the relationship that represents this table. And we can also go ahead and circle the last one because that's the same exact equation.